Welcome to Chemistry for 10 plus 2. Today we are going to see the numerical based on depression in freezing point. The syllabus referring here is the new syllabus which is of 2020 year. So let's begin with the numerical. Dear students, now we are going to deal with the numerical based on depression in freezing point. This numerical is from the new syllabus of the State Board, HSC Board textbook, that is of the year 2020. So before starting with the numerical, subscribe the channel, share it with your friends. Let's begin.
Good afternoon, students. Let's talk about the numerical based on lowering in vapor pressure, the colligative property which we have learned already. So let's see the numerical. As you can find here, the numerical is already I have written it. So let's begin and try to solve it. The vapor pressure of pure benzene having molar mass 78 gram per mole at a certain temperature is 640 millimeter Hg. A non-volatile solute of mass 2.315 gram is added to 49 gram of benzene. The vapor pressure of the solution is 600 millimeter Hg. What is the molar mass of solute? Okay, so in this numerical we have to find what is the molar mass of the solute. Before starting with any numerical, first of all you should know what is given, so that is to be written systematically, right? So let's see how it can be done. So let's start with solution. Now here first of all we should understand, here it is given vapor pressure of pure benzene at certain temperature is 640 millimeter Hg, right? So here pure benzene, the vapor pressure of pure benzene is 640 millimeter Hg. That means first given is P1 naught, that is vapor pressure of benzene. So 640 millimeter Hg. Then a non-volatile solute of mass 2.315 is added to 49 gram of benzene. The vapor pressure of the solution is, vapor pressure of the solution, that is P1, is 600 millimeter Hg. Okay. Then next is a non-volatile solute of mass 2.315 is added to 49 gram of benzene. So here benzene is the solvent and the non-volatile solute is 2.315. So benzene being solvent, we have to write here, this is second, this is third. So W1, 1 we are indicating for solvent. So benzene is the solvent, so that will be equal to here 49. So 49 gram. Whereas W2 is 2.315 gram. Okay, and here molar mass of benzene is given, that is M1. So M1 is 78 gram per mole. Right? So these things are given. So when you do in this way, it's very easy to understand what things are given and what is to be done. Now what is asked? What is the molar mass of the solute? So molar mass M2 will be equal to question mark. So we have to find this, right? Now when we have to find out the molar mass, by using this data, the formula we are going to apply here is P1 naught minus P1 upon P1 naught is equal to W2 multiplied by M1 divided by M2 multiplied by W1. So this formula already we have learned, and just put in the values which are given. So let's see that. So P1 naught here 640. So let's begin with that. (640 millimeter Hg) minus P1, that is 600, upon P1 naught 640 millimeter Hg, which is equal to W2 is 2.315 gram multiplied by M1. M1 is 78 gram per mole. M2 is to be found, so we will write M2 as it is, and W1 is given, that is 49 gram. Okay, now 640 minus 600 gives you 40. So 40 millimeter Hg divided by 640 millimeter Hg will be equal to 2.315 gram multiplied by 78 gram per mole divided by M2 multiplied by 49 gram. Now we will take this M2 on left hand side. So M2 is equal to 2.315 gram multiplied by 78 gram per mole multiplied by 640 millimeter Hg divided by 40 millimeter Hg multiplied by 49 gram. Okay, so on this side we are going to do log calculations Okay, so let's take the log of 2.315 0.3645, then log of 78 Since there are 2 digits here, so characteristic will be 1. So 1.8921. Then log of 640. Since there are 3 digits, so subtract 1 from it, so it will become 2. So 2.8062. Now we are going to add all these logs of all these, and the answer we will find it here. 5 plus 1, 6, 7, 8. So here 8, 2, 6 and 0 point and 5. Then take the log of 40. So log 40 equals to, since there are 2 digits, we can write here 1 point. The log is found to be 2, 1. Then log of 49. So 1.6902. This is to be added. This is also to be added. So here again we have to add, since these are to be multiplied, so we have to add here. So here 3, 2, 9, 2 and 3. Now this log, addition of logs of this minus log of these two. So 5.0628, this value, minus this, minus 3.2923. So the answer is 1, 8 minus 3 is 5, 0, 7, 7 and 1. Now we have to take the antilog of this. After taking the antilog, you will find here, as we are finding here the characteristic is 1, we have to add 1. So the answer is found to be this point, antilog of 0.7705 is 5895, right? So it is like this actually, 0.5895. Here it is 1, so we have to add one characteristic, so it becomes 58.95. Okay, so the answer is 58.95. So after doing this, we can, now let me tell you regarding the unit here. So here this gram gets cancelled, this gets cancelled, millimeter Hg gets cancelled with this one, and remaining is gram per mole. So here 58.95, so 58.95, and this unit gram per mole. So here we can write down, the question was what is the molar mass of solute. So the molar mass of solute is found to be 58.95 gram per mole. We can write it in this way also, or 58.95 gram. So this is how we can solve the numerical.
Subscribe my channel, like it, and share it with your friends. Hit the bell icon to get the notification updates. Thank you.